This is MATHguide.com. My name is Mark Karadimos. Today we're going to talk about proportions. I'm going to break up this video into several sections. Here are the titles of those sections. What's a proportion? We're going to talk about the picture aspect. We're going to look at what proportion visually looks like. And we're going to do two examples about how to solve proportions. Alright. What is a proportion? Well, a proportion is just two equal ratios. Like for instance, what's a ratio? Let's say we have 2/5. That is a ratio. A ratio just means a comparison between two numbers. So I've got 2/5, I've got 4/10. They're both ratios because they both compare two numbers. Now we know that when we have two ratios that are equal, it's called a proportion. And it is equal, right? If I multiply top and bottom by 2, I get 4/10. Right? 2 times 2 is 4, 5 times 2 is 10. You'll also notice that another property of proportions is that if you cross multiply, in other words, the numerator here times the denominator there, I'm going to get 20. If I multiply the denominator here times the numerator there, I get 20 also. That's another sign that you're dealing with proportions. So when you've got two equal ratios, those cross products have to be equal. In this section, we're going to talk about the visual representation of what a proportion looks like. Alright, let's examine this photo. Alright, in this photo, we could see several pictures of a human. And on the left side, you could see a picture of a baby. And you can see as we move to the right, the human is getting older. Now also notice within this picture that a picture is divided into sections. So there's a bunch of horizontal lines, and that breaks up this photo into 1, 2, 3, 4, 5, 6, 7, 8 parts. Okay, now the reason why these parts are of interest is because we want to take a look at some distances here. Alright, so the whole body takes on, let's say, 8 parts. Of the 8 parts, we could see that the head takes up 2 parts, right? 2 of the 8. So it looks like, if I reduce this, 1/4 of the body of a baby is just the head. I mean, you know, lengthwise. We were just talking about the length of this picture. So 1/4 of this baby's length is the head. Alright, now let's go all the way to the right side of the photo. Now again, we still have 8 parts. Of the 8 parts, only 1 part is the head, distance of the head. So there is a difference in proportionality between these two figures. The baby's head is large. When you know, a newborn baby does have a large looking head. Then when you look at an adult, the adult does not look like it has a large head. So it's like the body grows more and the head stays the same size. I know it doesn't appear that way in this diagram because it's just a different type of diagram. It's talking about relative lengths. But anyway, you can see it's the ratio that's of importance. So 1/8 of a adult human's head is, you know, 1/8 of the length is the head size. Over here, however, 2/8 or 1/4 of the baby's length is represented by the head. So there's a huge difference there. Also leg size. Here it's almost like 2 or actually like 3/8 is about the length of the legs approximately. And then here you're probably getting, I mean, if you look at all of this as the leg, this part is also part of the leg. Say 1, 2, 3, 4. So you would say 4/8, or about half the body is leg here, right? That reduces to a half if you divide the top and bottom by 4. So half of an adult body is leg. However, it's only 3/8 of the body of a baby is leg. So there's a different proportionality. And the legs kind of grow longer as you get older. Okay, so this does a great job of showing you why kids look different than adults. In this section, we're going to take a look at how to solve proportions. And I'm going to use two examples. So here's the first example. All right away you can see that we do have a ratio on the right and a ratio on the left. They're equal, so I do have a proportion. So earlier we said that proportions have a neat property. If we cross multiply, the product should be equal. So I'm going to cross multiply. 2 times 12 is 24. I'm going to multiply x times 3, and I'm going to get 3x. Alright, so I'm going to set these equal because the cross products should and must be equal for proportion. So to solve this, I'm going to divide both sides by 3. I get x is 8. Alright, so let's just take a look at the problem. So we have 2/8. Right? If x is 8, put that in there, is equal to 3/12. And we do get 24, and we get 24. Cross products are equal. Okay, let's get to our next example. Alright, here's our second example. And again, I've got a ratio on the right, a ratio on the left. Again, I'm going to solve this by cross multiplying. So I'm going to take 5 times 15, and I'm going to take 30 times y. So I'm going to set them equal, like I'm supposed to with the proportion. Notice I'm choosing not to multiply. The reason why is because to solve this, I need to divide both sides by 30. So it's just going to be easier for me to just reduce this. So in other words, I'm going to divide this by 15. I'll divide this by 15. Can't reduce it anymore. So it looks like you get 5 times 1 is 5 all over 2. I could choose to leave my answer as a 5/2, or I could actually divide to get a decimal, which would be 2.5. And sometimes we do solve proportions and we do get fractions or decimals, so this is very natural. Alright, so that takes it care for us when it comes to proportions. Check out our interactive quizzes, our instructional videos, and our text-based lessons at MATHguide.com. Take care.